Simple random sampling. Definition: each individual in the population has an equal and independent chance of being selected. Process: assign a unique identifier to each member of the population. Use a random number generator, lottery method, or random selection software to choose individuals randomly. Example: if a class of 100 students needs to be surveyed, the researcher could use a random number generator to select 10 random students. Advantages: minimizes selection bias. Provides a true random sample, which is representative of the population. Limitations: not always feasible for large populations, especially if a complete list of the population is unavailable. May be logistically challenging for very large or geographically dispersed populations. Systematic sampling. Definition: selection occurs at regular intervals from an ordered list of the population. Process: identify the total population size N and decide the desired sample size N. Calculate the sampling interval K by dividing N by N. K equals N/N. Start with a random number within the first interval and select every kth individual. Example: if a population has 1,000 people and the researcher needs a sample of 100, they would select every 10th person on the list. Advantages: simple to implement and saves time. Provides a quick, systematic way to obtain a sample. Limitations: can introduce bias if there is a pattern in the list that aligns with the sampling interval. Assumes an ordered and accessible population list. Stratified sampling. Definition: divides the population into distinct subgroups or strata based on certain characteristics, then samples each stratum. Process: identify relevant characteristics, e.g., age, gender, income. Divide the population into strata based on these characteristics. Determine sample size for each stratum based on its proportion in the population. Randomly select individuals from each stratum. Example: in a survey of university students across different academic levels, the population could be divided into undergraduates, master's students, and doctoral students. Samples would be taken proportionally from each group. Advantages: ensures representation of all key subgroups, making it ideal for diverse populations. Increases the precision and reliability of results, especially for comparisons between groups. Limitations: requires detailed population data to define strata accurately. More complex and time-consuming than simple random sampling. Cluster sampling. Definition: population is divided into clusters, often based on geographic or naturally occurring boundaries, and entire clusters are randomly selected. Process: divide the population into clusters, e.g., based on city, neighborhood, or school. Randomly select several clusters. Survey all members within the chosen clusters. Example: to survey high school students across a state, a researcher could randomly select several schools, clusters, and survey every student in the selected schools. Advantages: cost-effective and practical for large, geographically dispersed populations. Reduces the logistical effort of sampling across the entire population. Limitations: higher risk of sampling error if clusters differ significantly from one another. May not represent the entire population well if the chosen clusters aren't diverse. Each type of probability sampling serves different research needs and comes with its own advantages and limitations. Choosing the right sampling method depends on the research objectives, the nature of the population, and practical considerations like time, resources, and accessibility.